So it's lesson 1 of enterprise computing, and we're going to get our application set up in Visual Studio. If you want to open up Visual Studio, we'll set up the application. We'll kind of do a bit of a tour, what our ASP.NET application, how it's structured, how Visual Studio works. We'll make a few changes, and then we'll post everything to GitHub. So you get this screen. One thing that's neat is now you can turn this channel off, but Microsoft, they put out daily updates about things that are going on in the .NET world. So of interest to developers, they actually publish that channel right here. So to create a new project, we're not going to need to do this every week. We're going to create one project today, and we'll just keep adding on to it each week. But obviously, when you do assignments and labs, you're going to need to create new projects for those. So if you click on File, New Project, so you can see all the different options we have here. You can even build iOS applications in Visual Studio. So make sure you pick Visual C#, which is the first language. So we can use Visual Basic, we can use Visual F#. Visual Basic's really pretty much an old language. Yes, technically Microsoft supports it, but they want us to do our development in C#. So you pick Visual C#. These are all the different C# templates. And then if you click on Web, it narrows it down to 2 choices, .NET Core and .NET Web Application. So we want to pick the second one, .NET Web Application. We'll leave the box to create a new directory for the solution. I'm going to create Git new repository. I'm going to leave that unchecked. We'll enable GitHub manually later. So I'm just going to save it. I'll create a folder for our course. I'll call it PM Winter 2018. You don't need to do this, but this is just because I'm doing the same lesson week. Just create a folder somewhere on your machine. So I'm going to call this COMP2007 PM Music Store. You can call it anything you like, doesn't matter. I've just given it our course code and said it's the afternoon class, and I'm calling it Music Store. If you want to just call it MVC Music Store, that's fine. So give it a name. The default location will be in My Documents Visual Studio 2017 projects, but you can change the location of where it saves your project. So then just click OK. And then we get this window. So we have different options for different types of ASP.NET Web applications. We want to pick the MVC template. By doing this, Visual Studio will automatically add a whole bunch of files and libraries into our solution for us. So pick MVC, and then we're going to make 2 other changes to the options. Notice here over on the right, it says authentication defaults to no authentication. So all our pages are public. Later on in the course, we're going to want to deal with authentication and security. So we can set this up right now by clicking this Change Authentication button. And we want to change the option from none to individual user accounts. So this allows us to store user profiles in our SQL Server database. It will also give us the options, which we're going to enable in a few weeks, to use things like Facebook, Google, Microsoft login. So we're going to enable those later on. So pick individual user accounts. The other option here we're going to enable is this last checkbox on the bottom left, add unit tests. So you've probably done a little bit of unit testing in Java before. Well, we can do unit testing. It's baked into Visual Studio. So we'll have a couple lessons on unit testing towards the end of the course. But if we enable this now, it will add all the libraries and references we need to write and run unit testing later on. Okay. So just make sure you've picked MVC, individual user accounts, and unit tests. Okay? And then just click OK. Visual Studio will build the project. It'll take a minute. So you can see down in the status bar at the bottom left, all the files and references it's adding. So it's adding a whole bunch of Microsoft libraries. It's adding some front-end code. It's building some default templates and pages for us. So we get this screen when it's done. And then it should open this window on the right called Solution Explorer. So typically we'll want to keep this window open because it lets us navigate around inside the application. So it built a lot of stuff here. In fact, if I go to the directory where I just built this, so it actually gave us 99 megs worth of stuff. So there's a lot here. If I want to launch it, one of the other nice things that Visual Studio includes is it includes a built-in local web server. So we don't have to install a separate server like we did for PHP where we installed WAMP or MAMP server in order to run our application locally. It's included in Visual Studio. So there's a couple ways we can do it. The first thing that I suggest, now it sets up your default browser. Obviously, it always defaults to Edge or Internet Explorer because it's a Microsoft product. If you want to change the browser that's used by default, you just click this little black drop down here and pick Chrome, Firefox, whatever you want. And then if we want to launch our local browser, we just click the debug menu and choose this option. Choose start without debugging. We'll look at the debugger a bit later. Most of the time we want to start our server without the debugger active, and I'll show you why in a bit. So click debug, start without debugging. And what first thing it's going to do is it's going to compile our project. So take any C# code and generate a DLL, a binary file. So this process takes a minute. And we can see in Visual Studio, once it's done, it told us our solution was built successfully, and it created a DLL file, the same name as our project, and it stores it in the bin folder. So this is what we have to deploy to the server. We don't have to deploy the individual .cs code files. And now in my browser, because I picked Firefox, it launches a local instance, randomly assigns a port, and I actually have a working application, even though we've done nothing except set it up. Visual Studio auto-generates all this stuff. So we get a little navigation bar. It actually gives us 3 demo pages. We've got a shared header and footer, so we have some kind of templating system for layout. We even have these pages that got enabled because when we set the project up, we picked individual user accounts instead of no authentication. If we picked no authentication, we wouldn't have those links or these pages being added. So it actually builds a number of views for us. It includes Bootstrap. You can probably tell from the theme. And right out of the box, we've got a mobile responsive site. So our navigation uses Bootstrap. Now, we don't have to use Bootstrap. We can get rid of this. We can make any changes we want to the CSS. We could add our own theme. We could get rid of Bootstrap. We can do whatever we like. So the whole idea when Microsoft first created ASP.NET, which was 16 years ago in 2002, the idea was they asked themselves, developer, and they build site after site, what are the routine tasks that they have to manually do over and over and over again? And we want to automate all that stuff in Visual Studio. So our developers can focus on designing, developing, testing their applications rather than doing mundane tasks over and over again. We can just program Visual Studio to build those things, like templates, like login screens, etc. Incidentally, the very first version of Visual Studio.net that came out in 2002, I bought that. I paid bought a professional license. Want to guess what that cost me back then? Probably the enterprise version would have been $5. The professional version, which I bought, it cost $1,700 US. So it was a little over $2,000 Canadian I paid for that license. So when they came out with version 2005, I kept going with 2002 as long as I could until I really had to upgrade to 2005. I'm not sure what it costs these days. You guys get it for free on Imagine. Curious. Maybe we'll check what Amazon sells it for. Let's see if we had to go ahead and buy the professional version. Okay, so this one's, these are US prices. Here's enterprise, $300. So the price has come down a fair bit. It's no longer $2,000, but still not free, not cheap. Right? The community edition is free. The community edition is supposed to be for learning. It's not supposed to be for doing paid work. So let's kind of do a bit of a tour and see what we get here. So the references, most of this 100 megabytes worth of code is in these references. So we have references to things like Microsoft Entity Framework. This is the ASP.NET library that's like PDO for PHP. This is the library we use to connect to a database. And we'll use this in the next week or two. Maybe not for a couple weeks till we deal with models. We've got a couple of references, some libraries called ASP.NET.Identity. That handles our authentication. So things like user registration, login, making pages private, or controlling what types of users have access. OWIN is another package, and you can probably guess what these packages are. They should be self-explanatory based on their names. Right? So if we want to do Google authentication, the library we need is already here. All we need to do is call the methods in there. It includes a JSON library. So what might we want to use JSON for in our web application? Where do we commonly see JSON on the web? Anybody work with JSON before? So JSON stands for JavaScript Object Notation, and it's the common format for REST APIs. So we want to consume data from a web service. It'll send us that data. We'll send a request in JSON. It'll send us JSON data back. So this library gets included in case we want to integrate our website with a REST API. We've got a bunch of other .NET libraries here. And this one, .razor. Razor is the name of the view syntax that we use for all of our HTML views in ASP.NET. We'll just close that up. Occasionally, we might add additional references. If there are other code libraries we want to add, we can add the reference. Or sometimes we may have to update these references because the versions get updated. I think the Facebook, for example, the Facebook library that we installed, when we go to do Facebook login, that version is old and it has a bug in it and it won't work until we update the version. So we can do that. We've got a bunch of startup files here. We'll modify a few of these later. Like one of the things we're going to want to do later on is get our application to use an SSL certificate. So we want to force every request, instead of using HTTP, we want it to use HTTPS. So we're going to go into this filter file and we can add code that will force any unencrypted requests to get redirected to an encrypted version for extra security. Okay, so we'll modify a few of these files later. So this is a default file. So this shows us how our application is going to map URLs to the controllers and views, right? So we kind of already diagrammed this out. how a URL gets interpreted to a controller and method. So there's the code that actually does that. So if we want to change the pattern of our URLs, that's fine. We can overwrite this code. So here we've got controller, then the method, and then the parameters. So if we want to change that, we can override how our URL structure works in this file. We'll probably just leave this alone because it works pretty well. For content, this is where we put static assets. So things like images, media files, and style sheets go in the content folder. So it gives us Bootstrap. It also gives us a default style sheet of our own. So if we want to use Bootstrap and some custom CSS, we can just modify this file or add additional CSS files of our own. We'll maybe make some changes to this in the next week or two. If you don't want Bootstrap, that's fine. Just delete it and get rid of it. So we've got a folder for controllers. So this account controller, that handles all the logic around user authentication, registration, login, forget password. We don't have to write this stuff. Microsoft gave it to us. So it's got methods if we want to do two-factor authentication, registering, all this stuff's here. Now we can modify this code, but it's a starting point. If we look at the URLs here, so notice when I go to home, it takes me here, home about, and home contact. So we can assume there's a file in controllers called home controller. We can see that from the URL pattern. So if we open our home controller, it makes a few references. It says this file is a controller file. And we've got 3 public methods here, right? Index, about, and contact. So in each one of them, the public method, it returns an action result. So that's our return type. And in each of these cases, what happens is the method returns or loads a view in the browser. When we return a view, notice it doesn't have to specify the name of the view. So how does it know? So how does MVC know to reload the view called index in this case and load the view called about in this case? Because we're not specifically saying which view to load. It just seems to know. How do you think that happens? We have methods called index, about, and contact. If we open up views and home, how many files are going to be in there? 3. What are the names going to be? Index, about, and contact. So every controller method will automatically need a view with the same name. So there's our controllers. If we have fonts, they go in here. Later on, we'll create models. So our models, they basically match or correspond to tables in our database. So if we have 10 tables in our database, we're probably going to have 10 model files, each model representing or mapping to a table in the database. And Visual Studio has some really neat tools for this. There's 2 ways we can do this when we build a new application. One option is called the model first option. So that's, we set up a database, but that database is blank. Visual Studio will let us create models. Those models will look just like the same kind of classes you create in Java, where you set up properties with gets and sets. And then Visual Studio, if we create all the models, it will generate a database from our model. So if we have 10 model files, it'll build 10 matching tables in the database. The other option, we're going to do the opposite, which is called the database first model. I'm going to give you a script to build a database next week. It'll create 6 or 7 tables and insert data into each one. And then we'll use Visual Studio, and it will automatically generate models that match the tables in our database. So it means much less work for us, and it means we know that our models will accurately reflect our database. So we'll get into that in actually a couple weeks before we do that. The scripts folder, all our client-side JavaScript. So it's got jQuery, it's got Bootstrap's JavaScript. Any other custom client-side JavaScripts we want to write, we could just stick them in this folder. The views is where all of our HTML files go. They get this extension, .cshtml. So for each controller we make, we either will make a subfolder in views ourselves, or we can actually get Visual Studio to auto-generate this. Remember I said it's big on doing stuff for us. So if I go ahead, I won't save this, but if I add a controller, excuse me, we have a few options. I can just make an empty controller, but most of the time we're going to pick a controller with views. So if we create a products controller, Visual Studio will automatically create a views product subfolder and create 5 views in there for us. And those 5 views are designed to do the create, read, update, and delete methods. So we don't have that today, but we will. So for each controller will have its own subfolder with its own set of views. We also have inside of views, we have a shared folder, and we have a few things in here. We're going to use this file a lot, this underscore layout.cshtml. So here's what it looks like. We can make whatever changes we want. What do you think the purpose of this file is if you look at the HTML that's here?
Navigation.
Okay, yep. So it goes on there. So that's part of it. What's the purpose of the file in general? Not just navigation, but a little broader. No, you're close. This is the index page here, though. Right? There's the content of our home page. So what's the purpose of this file? It has navigation, but it has more. What else do you see on here besides the nav bar? So our nav section's here, but there's other things on here besides just our nav bar. What is the code above and below the navigation bar for?
Whole structure of
Yeah, it's our site design and layout. It's a layout template. So all the pages can inherit this layout. Or it'll get any CSS links, it'll get any JavaScript links, header, footer. So it's our template for laying out the pages. So we get one layout file by default. If we have different page layouts, we create different templates. We can create multiple layout templates, right? Maybe we have a public layout. Maybe for our admin site, we have a totally different layout. So we'd create another template inside of shared. So it's got the navigation, the header, footer. This render body, this is where the individual page content gets injected. So the content for the index page gets injected below the first 32 lines. That's why when we click from one page to another, we've got the same header and footer, and then the page content in between the nav bar and the footer is the same. So they've set this up. Let's make a couple changes to it just to see how it works. So first, let's change line 6. Let's change the title. We don't want it to say myasp.net application. Let's have it say MVC Music Store. On line 6, we'll make that change. You notice I now get this little green bar beside line 6. Visual Studio will show me what lines I've made changes to. So if we save that change, we should be able to go back, refresh, and the title of our browser tab should get changed. So now up here it says MVC Music Store, and because that's in our template, every page inherits that change. Let's change a couple other things. Let's change this link here that says application name. Let's also change that to say MVC Music Store, and then we'll change the footer as well. So on line 20, now you notice we've got this HTML action link. This is new, probably never seen this before. This is ASP.NET server-side syntax for generating a link. We could just use a regular ahref tag, but normally, .NET MVC applications, we use this HTML library and the action link method instead, and I'll explain how it works. So we can see the parameters of this method. So the first parameter is what is the text that displays on the link. Right now our link says application name. Well, we want to change that. So let's change this from application name MVC Music Store. So that should make a visible change in the browser. Right, if I save that and refresh, it no longer says application name, it says MVC Music Store, which is better. So how does this method work? So the first parameter is what text is on the link. What do you suppose these next two parameters indicate? Index and home. What are those referring to? My little code hint in Visual Studio should give you a clue.
The expansions to those pages, pretty much.
You're on the right track. So the first parameter is the text of the link. The second parameter is the action name. What is the name of the method this link calls? So in .NET MVC, we don't really think of links loading pages. Links call a method, and the method loads a view. Because remember, we've got this MVC architecture. So we don't link to views directly typically. We can, but we link to a method. So the method this link is going to call is our index method. So what does the home refer to? Good guess, not the view. Actually shows you right in the code hint. So the third parameter here is the controller name. So it's the text on the link, the name of the method we're calling, and then which controller we're calling that method in. Because all our controllers might have an index method. So this is calling the index method of the home controller. It's going to go to our home controller, call the index method, which will return the view home/index. That's how this works. So we'll save that. And if you look at these links down below, that may help make it a little more clear. Right? We have 3 links with the text home about contact. Each one calls the home controller, but each link, the home link calls the index method, the about link calls the about method, and the contact link calls the contact method. So when I click that, it calls home index, which loads the views home index. Action link is new. It'll become more familiar. And we can also attach an optional parameter. In this case, they've attached a Bootstrap class so that the text is a little bigger on that first link. We can also change the footer down here on line 36. It says my ASP.NET application. We'll change the footer down here. I'll put in our course code and our semester code. So this will always display the current year, which is much better than hard coding. We don't want to hard code the copyright year in the footer. Otherwise, every January 1st, we have to go on all our websites to change the year, right? Let's use server-side code to dynamically get the current year. Just pretty simple, datetime.now.year, built-in C# function. So now we can navigate around and the footer's changed on all three of our pages. Now you'll notice wherever we see the little yellow @ symbol, what's the purpose of that? What do you think? So we have it here. We have it here before our year, before this render body. What do you suppose this yellow @ symbol is indicating? We haven't seen this in web pages previously. We didn't use this with PHP or with plain HTML. What do you think it means?
Using a reference?
Yep, you're right. Reference to, what is it referencing? When we wrote a PHP, close. Well, let's look here for a minute. We'll just compare it to a PHP file. We've got two languages in this file. We've got HTML and we have PHP. When you look at the file, how do we know which is the HTML code and which is the PHP code? What distinguishes them?
PHP is within the PHP tag.
Right. All our PHP, all our server-side code goes within opening and closing PHP tags, right? So our @ symbol indicates this is server-side code that's injected in our HTML. So instead of opening and closing tags in ASP.NET views, we just use the @ symbol to start, and there is no closing tag. So the syntax, it's easier to read and it's easier to type. An @ symbol, and it turns yellow, so the compiler knows this is server-side code, either a method we're calling or a reference to a server-side variable, right? Like here, the page title. And in this case, yes, they're method calls. Okay. What did I want to do next? Oh. So I just want to show you exactly something here. So notice, we'll talk about this Viewbag object a little more. I'll explain briefly what it is. We use it a bit. So the Viewbag, notice in our About page, we're setting up a property called message and giving it a value. And if I open up the About view, here's all the HTML, right? So it uses our template for the header and footer, but here's the page content. Excuse me. So we have an H2 tag with a title and an H3 tag. And both of these have the @ symbol, so those values are coming from the server, from our C# code. And then we have some static HTML on here. Let's add one more paragraph. I'll just add in another paragraph tag, save it, and I'll refresh my About page in the browser. So there's our new content. So if we want to change the HTML in a page, we can just update the view. Hit save. Page is updated, no problem. What if we want to change, though, this message because this message is coming from the controller. It's being set in the server. So we're setting that message here in this Viewbag object in a message property. And then we display it here at viewbag.message. So let's change this here. Instead of it saying your application description, let's say this is the about page. We're changing the value that our controller is going to set and pass to the view. So let's save that change and then go back and refresh your about page again. I'm going to go to about. Now notice this time, when we made the change in our controller and I go back to my about page, my content has not updated. It's still saying your application description page. We want it to say this is the about page. So what's happening? Why is our page not being updated? When I made the change in my view and hit save, it updated in the browser. But now I've changed the controller, hit save, refresh my page, but it's still showing us the old content. Why? Where does all of our C# code live? Or the C# files, these are just our source files. They're not used at runtime by the web server. At runtime, the web server uses our binary file, our DLL file. My DLL is from 1:42 p.m. from when we first created the project. So even though I changed the C# file, the C# file will be timestamped now, but my DLL hasn't been updated yet. So what do we need to do in order to get our change included in the binary? We don't need to upload because we're doing it all locally. If you make a change to a Java file, what do you need to do in order to see that change? Yeah, we need to compile. We need to recompile our binary so that it includes our updated C# code. So the way we do that in Visual Studio is through the Build menu. Click on Build and build your solution. So now it's going to take all the C# and recompile that DLL. So it is a bit slow. So it built. Now if I go back, notice my DLL in the bin has been updated to now. So now we've recompiled. So our C# code, if I click on About, the first request after a build is always slow because it has to rerun accessing all the binary code. So that first request, there's a lag. Now our page has been changed. So the lesson is whenever we modify the C# code, any of the .cs files, you have to build before that change takes effect. The views we can change without compiling because those are just HTML. So we do spend a fair bit of time waiting for our project to compile and then waiting for that first request after a build. So this Viewbag is an object we'll use a little bit. It's largely just used for passing small values or text values back and forth between our controller and our view. We want to display a message or something. We can set it in the Viewbag, and then we have access to output or display that Viewbag, those Viewbag properties in our views. We don't typically, when we're looking up data and working with data objects, we're not going to use the Viewbag. So on a page like this, we actually want to send back a full product object with all the properties of product ID 123. So when we load a product details view, we can actually pass it a strongly typed object. And then in our views, we have access to all the properties and methods of that object. So our code, all our applications, fully object-oriented in ways that our PHP applications are not. As Rick said, technically we can do PHP that way, but it's not really designed that way. Any questions so far? I do also want to show you two other things, and then we will be done for the day. I said we use start without debugging. So that starts our web server. There is also runtime debugging, which means we can load a page in the browser, and then we can use the Visual Studio debugger to walk through our code one line at a time so we can evaluate what's happening, which is really useful if either we get errors or if our web page is not doing the things we're expecting it to do. So I'm going to show you how that works. You've probably used debuggers before in Java, with Java, but we can do that actually with web pages. So let's do this here. I'll just write a little bit of code in my about method. I'll create a few variables. I'll create a couple integers and then I'll just add them together. You can see what's going on. So I'll save this, and then what I want to do is once the about method is called, I want to walk through the code one line at a time at runtime so I can evaluate what's happening. So if I click over here on the left, there's kind of a little gray bar beside the line numbers. I'll put in a breakpoint here. And then I can either click the play button or I can just click debug and start debugging. So this will start a new instance of my server. But now my debugger is active. Every time you do this, it builds the site again, so it is a bit slow. So we don't want to be running it this way all the time, just when we need to debug. So now I've got to wait for the compiled version to load again. So I can, click around my links, but as soon as I click about, it transfers execution to Visual Studio, and now I can evaluate my variables and watch my code execute one line at a time. So X initialized to 0, I just put my mouse over the X and Visual Studio pops up as 0. To go to the next line, I hit F11, and now X has a value of 4. So Y is initialized to 0. I hit F11 again. Y is 3. And now it adds it up and shows me the value of those variables. So then if I want to just keep going, I press continue, and it takes me back to my browser. So this is a huge help in debugging. When our application either generates errors or doesn't give us the results we want, we can use the runtime debugger. Now, normally I run my application without debugging. Here's why. When the debugger is active, you can't make any changes to your code. So some students, they always start the debugger, but every time they change it, they have to stop the server and restart, stop and restart over and over again, which is not a very efficient use of your time. If I want to keep making changes, I need to press stop. So now I can make changes again. But once I press stop, I've taken the server offline. So if I go and refresh, it says your server's down. So 99% of the time, we will start without debugging, because that way our server just stays running and we can make changes and keep building. But if we need to use the debugger, we turn it on, we start debugging. When we're finished and we want to go fix our code, we hit stop. We change the code, and then we've got to do start without debugging again in order to put our server back online. So I'll just start it back up without debugging. A couple of other neat tools. Notice when I had the debugger running, it shows me how many requests were made at each of these methods and whether those methods were successful. So it says you ran about once and it worked. You leave a green check mark. You ran contact once. You clicked on index twice. So we can do a little stat tracking. It also later on will tell us when we write unit tests, each method, it'll tell us how many tests there are of this method and how many of those tests pass, which is helpful. Okay, we're going to make one more change to the application. We want to build a new page and add a link to it. So we're going to do three things. We're going to add a new method to our controller. We're going to build a new view with the same name as our new method. And then we'll add a link in our navigation bar so we can click on that link and load our new page. Then we'll put our stuff up on GitHub and call it a day. So in your home controller, let's make a new public method. Public, it returns an action result. And we're going to call our new method services. We'll make a page called services. So all we want this method to do is load the view called services. So this will just return the view with the same name. Now, probably in this course, we're not going to do it. But if we ever wanted to have different names for the method and the view it loads, we can do this. All we would have to do is specify the name. Oops. So we wanted our method called services. This would then look for a view file called some other view name.cshtml. If we leave it blank, it automatically looks for a view that has the exact matching name, which is what we want to do most of the time. So there's our method, pretty simple. So now inside of views and home, let's right click and add a view. We call it services. The template is empty without model because we're not using our database for this. And it's giving us the option to use a layout page, which we want to do because we want the header and footer that the rest of the site has. So if we just click this little browse button here beside the use a layout page and choose views, shared, we can pick our layout template. Then this page is going to look like all our other pages. And click add. So it gives us a basic page, sets up a title, links to our layout file, and gives us an H2 tag with the name of the page. I'll just put on a text. We've created the method, we've built the view with the same name. Now we should be able to try it out. So I'll go back to my site and I will go to /home, because it's in the home controller, /services. URLs on Windows are also not case sensitive. So unlike PHP, I could type this fully lowercase, it's still going to load. even though my view name has a capital S and my method name has a capital S. Doesn't matter. Okay. So why do we get a 404? We have a services method in the home controller, and we have a view inside of views home services. So why do we get 404? We didn't build, right? We added a new method to the controller, but that method can't be invoked until we build. So just go back and build your solution, and then we should be able to refresh, and that page is going to show up. So we built. Refresh now. There we go. And just to prove it, not case sensitive, I can run the same URL, all lowercase, and it's fine. Our C# code is case sensitive, but the URLs are not on Windows OS. So the last thing we want to do is let's just add a link in the nav bar. So which file do we go to if we want to modify the nav bar? Yeah, let's just go to the layout file. And down, so our last link is on line 26. So let's just add one more list item, and we'll use that HTML action link syntax. For our link text, we'll say services. And remember, we're calling a controller method rather than loading the view directly. We want to call the services method that we just wrote in the home controller. If we save and refresh in our browser now, we should have a services link that we can click on and load our new page. There would be nothing wrong with just writing a plain old HTML link. We could just write ahref equals /home/services. That would work. But if we're using this pattern, it makes sense to use action link because it's a little more explicit that we're using MVC and how our application actually works. Gets us in the mindset of we don't load views directly, we go to the controller and the controller decides what to do. So now I can refresh, and now we've got our nav bar. So adding new pages is as simple as that. Create a method that returns a view, create a view of the same name, put a link somewhere, use HTML action link wherever it goes, whether it's in your nav bar or a text link, a button, whatever kind of link is appropriate to let a user get to that page. Okay. This is as much as I wanted to do today. I just kind of wanted to get started so you can see how Visual Studio works and how the MVC pattern, how the pieces start to fit together. It'll be a few weeks before we get into the model and the database part. We'll work a bit more with the controllers. The week after, we'll really sort of focus on the views. And then in class 4 is when we'll wire up our database, look at the whole model piece and how we start working with dynamic data in here. And all the stuff Visual Studio is going to nicely automate for us, all the work it's going to save us. Okay, so the last thing I want to do is I want to put my repository up on GitHub. Repository, I'll upload what we did today on there, and then each week I'll just keep adding on to it. So the first thing I'm going to do is go to my GitHub account. Now, there's several ways we can get our code up on GitHub. You might use the GitHub desktop client, which I'm not a big fan of. There is GitHub integration right in Visual Studio. It's through this little Team Explorer window. When it works, it's really great and works simply. I find it often doesn't work, though. And when it doesn't work, it's hard to undo or redo stuff. So I'm going to use the command line because I find we have a lot more control through the command line if things don't work. So the first thing we need to do is we need to create a repository on GitHub. So I'll just click on new repository. I'll call it COMP2007 PM Winter 2018. You can just call yours, you know, MVC Music Store. I'll give it a description, or ASP.NET MVC Music Store. I'll make my repository public, so obviously all of you have access to it. We'll come back to the Git Ignore. I'm going to leave out the README file. We'll build that later. So I'm just going to create the repository. Now it's going to give me most of the commands that I need to run in order to upload to GitHub, although we're going to have to modify a few of them. The one other thing we want before we push this up and set this up with GitHub is we want to set up the Git Ignore file. Why? Because our project's 100 megs. Almost all of that code is in this packages folder. So these are all the support libraries. So if our whole project is 139 megs, I think 99 of that were all of the support packages. There's no need for us to upload that stuff to GitHub. It's a waste of storage on GitHub. It's a waste of bandwidth. So we want to use a Git Ignore file so all the packages don't get included. So I've put the Git Ignore file you need on Blackboard. So inside of Tools and Resources, you just go back in here. The second last item is a Git Ignore file for Visual Studio. So I'm going to right click and say I'm going to open this. It's going to try to open it in Notepad, which is fine. And then I'm just going to save this into my root project folder. So there's a lot of stuff that we want to get ignored from Visual Studio. So I'm just going to click File and Save As. And I'm going to copy it into the folder with my project. Make sure I save it with the name .gitignore. And by default, Notepad wants it to be a text document. I'm going to choose all files because otherwise Notepad's going to add a .txt extension on the end, which I don't want. So it should be, the file name is .gitignore, save as type is all files, and I want that right in the root folder. So I'll just save that. So now if I look in my directory, I can see I've got my Git Ignore file here, right beside my solution file, which is my SLN. So you can browse into your directory in Windows, make sure you see the .gitignore file here. And then I'm also going to need this path in my command prompt to get Git enabled in this folder. So once I've got my Git Ignore file here, I'm going to click in my address bar and copy the path. Later on, I'll show you how to get here straight through Visual Studio. It'll save us a step next week. So now I'm going to open up a command prompt. So I'll click Start, and in the search bar, I'll search for my command CMD, which will take me into my user directory with my username. So I want to get out of this directory, and I need to go into the directory that holds our Visual Studio project. So I'll type the command CD for change directory, and then you can just right-click and paste. Excuse me, you can paste the path and hit enter. So now my command prompt is I'm at the same place as I am in my Windows directory. I am recording this, so this will be on video. If you're going to try it at home, you run into a problem. So now we're going to run most of these commands that GitHub gives us. So the first thing we need to do is we need to initialize Git in our local folder. So Git will start watching for changes. So if I run the command git space init and hit enter, it'll initialize a new GitHub repository here. It'll tell me it initialized an empty Git repository. The next thing I want to do is add all of the files to my local repository. So I can do that with git add dot. Dot is just the wildcard, all files, so all file names, all file types. So I'll hit enter. So this is going to add all of our project files, except for all the stuff that was in the git ignore. Now we need to make our first version. So we need to take a snapshot, which is git commit -m. I'll just call it lesson 1. And I'll hit enter. So it's now created a local archive, a local version on my computer with the message lesson 1. So I have a local version, but it's not on GitHub yet. It's only archived on my own laptop. So now I need these two commands. I need to add the remote that connects my local GitHub repository, my local Git repository to this one on GitHub. And then I just do a push, which will upload my files. So I'll copy this line from the GitHub prompt, paste it in. So now I'm connected. And then I'll run the last command, git push -u for unconditional origin master. Or I could copy and paste it. And now it's uploading. Doesn't take very long because we excluded most of the code, which is all those reference libraries. So if I go back and now reload my repository, rather than the instruction showing up, all our code is here. Notice the packages folder is excluded. The git ignore excludes the packages folder. So it's just uploaded. And it shows my latest commit message, which said lesson 1. So this is public for you. So if you need to reference anything here, you can always go and look at my repository, or you can download it as a zip file. Just click this clone or download and download it as a zip file. You don't want to clone it. You're better off to download it. So we used init, git add dot, git commit to make our first local version, then connect to the remote and push. And that'll put our code up online. So we're going to do this a lot. I will show you, as I said, a couple ways that might make the process a little simpler. If you want to use the desktop tool or do it straight through Visual Studio, you certainly can. That's fine. I just like the control that the command line gives me. Okay, it's 2:38. So I think we can wrap up for today. There's no week, so nothing you need to do. There's no labs or anything. So what we'll do next week, we come back into class, we'll look a little more carefully at the controller. So we'll basically just open up the same project next week. We don't need to go through the setup. Setup's already done. We'll look more at how do we do things in the controller, some of the other things we can do. And at the end of class next week, we'll just upload and push what we've done onto GitHub again next week. Okay, so video stream, I'm going to stop the video now.